All right, today we're going to talk about data gathering. Make sure you got your notes. There's a lot of definitions on here that you'll need to circle, highlight. I'm going to circle them on here. Most of them are in bold or underlined, but just make sure you know what these words mean. Okay. So a lot of times you guys have been a part of a survey, but there's more than goes into a survey than just say, hey, we're going to go pick a random group of people and see what they think. Okay, so surveys, like it says on here, are often conducted to gather data about a certain population. Okay, and population is one of the other key words because population is the entire group, emphasis on entire group of people or objects that you want information about. Okay, so that's everybody. Now, oftentimes you can't take a survey of everybody. If you do, it's called a census. It's a survey of the entire population. You've probably heard census when, parents have to do that every 10 years. Talk about, who's in your family, etc. That's where they get population numbers in countries and states. You get those from the census. But the census is the entire population. But oftentimes it's too difficult, expensive, or time-consuming to conduct a census. So you want to look at a sample, which is just part of the population, and you want to try to survey a sample that will help you to make a prediction about the population, whether what people like, what people are going to do, where people eat, etc. Okay, but it's important to make sure that your sample is random and that it's representative of the entire population. So when every member of a population has an equal chance of being selected for a sample, the sample is called a random sample. This is the best type of sample. It gives you the best information. Also called a probability sample. But these random samples are most likely to be representative of the entire population. It says of a population, but it's talking about of an entire population. They are preferred over non-random samples, such as things like you see convenient samples and self-selected samples. A lot of times when people take samples, you got to make sure that it's not out of convenience. If you're a restaurant owner and you want to test, how many people eat out in a week, you wouldn't go to your customers and say, hey, how many times you guys eat out in a week? Because they're already eating out. They're more likely to eat out than the rest of the people in a city. Okay, so you didn't have a really random sample there. That was convenient for you. All right. One thing that I want you to make sure you understand is that random samples are better than non-random samples. Okay, so random is better than non-random. And again, I'm just hitting some bullet points here. All right. And the reason for that is the more random the sampling, the more likely it is to be representative, okay, of the entire population. So you would write likely to represent everyone. And when I say everyone, that is the whole population of whatever is being studied. Okay, so an example of a population may be, you want to survey the kids in our school about, class change times. All right, so the population there would be every student in the school. Now, it'd be hard to get to all of them. It'd be a little easier now with our Chromebooks and stuff, but it'd be hard to get to all of them, so you might say, you might have somebody posted at all the entrances each morning, and you say, hey, we're going to take a sample of every fifth student that walks into the building in the morning. Okay, that would be random. Okay, because every student that walks into the building, which every student walking into the building is every student in the building, would have an equal opportunity to be surveyed. Now, if you said, I'm going to take a sample of every student at a lunch, that would be a non-random sample, okay, because not everybody has access to a lunch. All right, so you'd only be sampling students in a lunch. So you got to make sure it's as random as possible so that it represents everyone in the population. So Random, random samples are less likely to be biased. Now, you're going to see this word a lot today, while non-random samples are more likely to be biased. Bias is where you prefer one side over the other, or you're leaning heavily to one thing over the other. So what I just said, where if you only surveyed students in A lunch, that would be biased, okay, because the students not in A lunch would not have an opportunity to participate in your survey. Now, the first example I gave where you're testing every fifth student that walks into the building, that would be unbiased. Okay, because every student has to come to the building to be in the population, so every student has a chance to be in your sample. So bias in a sample is not always obvious at first glance. A statistic, okay, a statistic is a number that describes a sample. So once you find all your data, your statistics describe what happened in your sample. A parameter is a number that describes the population. Okay, so statistic, sample, parameter, population. You can use a statistic from a survey to estimate a parameter. In this way, surveys can be used to make predictions about a population. So if you're predicting a parameter, you're making a prediction of what the entire population would choose. And oftentimes surveys are used for those predictions. Okay? So make sure that you understand your stat from your survey is used to estimate or predict the population or estimate a parameter. Because parameter goes with population. So let's look at some examples, and you're gonna be asked different questions about, is it a random sample, is it biased, is it unbiased, and then you're going to be asked to figure some things out too. All right, this example, this wildlife application, says a researcher is gathering information on the gender of prairie dogs at a wildlife preserve. The researcher samples the population by catching 10 animals at a time, recording their genders, and releasing them. Okay, so if you look at the 4 samples over here, each one, the combined numbers in each sample add up to 10. Okay, 5 and 5 is 10, 7 and 3, 4 and 6, 8 and 2, it's all 10. So there were 40 total that were recorded in his sample. Okay, so the question is, how can you use this data to estimate the ratio of males to females in the population? So, some things we should write down here. Population is the entire group being studied. The entire group studied. So, in this case, the population, I'm going to abbreviate, is the total number of prairie dogs on the preserve. That would be the entire population. Okay, we're going to make an estimation about that population. He only caught 40 of them. Okay, now it doesn't tell us anything about the number of the entire population, but we know that his sample was 40. Okay, so we need to write that in. The sample is the 40 prairie dogs caught. So they're designed to represent the entire population. Now, in the chart up here, we see that out of these 40, we add these numbers right here in the male up. 5 and 7 is 12, plus 4 is 16, plus 8, that's 24 males. All right, 5 and 3 is 8,
plus 6 is 14, 15, 16. There's 16 females. So the ratio of males to females, okay, there's 24 males to 16 females. So if we wrote that out as a ratio, we would write it as 24 to 16, males to females. Then you'd want to reduce that. If you look at 24 and 16, 8 goes into both of those numbers. 8 goes into 24 3 times. 8 goes into 16 2 times. So the estimate would be that there is about a 3-to-2 ratio of males to females in this population of prairie dogs. So the last thing we'll put right here is an estimate. And this estimate is about the population. And I would say the approximate ratio of males to females is 3-to-2. And then notice I said approximate because we're making an estimation. All right, move to the next slide. You've got to identify the population and the sample. That's what it tells you to do right up there at the top. So the population, remember, is the total. All right, and the sample is what you're surveying. Okay, so right here it says a car factory just manufactured a load of 6,000 cars. So 6,000 is obviously one of those things. The quality control team randomly chooses 60 cars and tests the air conditioners. They discover that 2 of the air conditioners do not work. Okay, so if we're going to identify the population, that's everything that could be studied. Well, the population is that 6,000 cars. The population will always, always, always be larger than the sample. Okay, when you go to the, the candy store and they let you sample the candy, they don't give you the big piece, they give you a little piece of it. That's the sample. Okay, so the sample here would be the 60 cars that are randomly selected. Population 6,000. The sample is 60. And this one is actually a good sample because it says randomly chooses 60 cars out of the 6,000 that were manufactured. So there's really no bias here. All right, when you look at the next one, it says decide whether each sampling method could result in a biased sample and explain your reasoning. All right. A survey of a city's residents. So that's every person that lives in the city. That's what we're trying to survey. Every person in the city is conducted by asking 20 randomly, okay, randomly, that's good, selected people at a grocery store whether the city should impose a beverage tax. Now, you know as well as I do, in our city, there's 2 Harveys, there's an IGA, there's a Walmart, okay? So if we just chose one of those grocery stores and we tried to, we wanted that to be a representation of everybody in the population, there's also Publix, then that's not random at all. That's definitely biased because they're only targeting people at this one grocery store. Even though it says randomly, they're randomly selecting them at that grocery store. So what you would want to say here is that the people who do not shop at that grocery store are underrepresented. And remember, we said that bias was underrepresentation or overrepresentation. Okay? And you can continue going. It's only the people that shop at that store would be represented. So the sample is biased. Only the folks shopping at that store are represented, so the sample is definitely biased because the population is every person in that city. And not everybody in that city is going to shop at that store. Look at the next example, same thing, we're looking for a bias. A survey of students at a school is conducted by asking 30 randomly selected students in an all-school assembly whether they walk, drive, or take the bus. So, good, we're randomly selecting. All right, a survey of students at a school, that's all the students. So all students need to have an opportunity to be in the survey. In an all-school assembly, guess what? Every student in the school is at that assembly. Every student has a chance to be one of the 30 randomly selected. So, does this method or does this survey have any bias in it? Okay, so you would say no particular group is under or over represented. Therefore, this sample is not biased. Every student in the school has an equal opportunity to participate in the survey, in the sample. Right, look at the next example. Decide whether each sampling method could result in a biased sample. Explain your reasoning. Okay, so we got the same thing we just did. So here it is. It starts right here. An online news site. Now it's a news site. Ask readers to take a brief survey about whether they subscribe to a daily newspaper. Now, if you're on an online news site and you're a person that reads news, you're probably more likely to subscribe to a newspaper than just Joe Schmo surfing the internet. Okay, so this particular instance, this particular sample is biased. Okay, so we would say this is biased because people visiting a news site are more likely to subscribe to a newspaper. If they're a person that enjoys reading news, they're on a news site reading news, they're probably more likely than others to subscribe to a newspaper. So this definitely is biased. All right, go to the next one. Car dealer. We're looking for the same thing. We're looking for bias. Car dealer wants to know what percentage of the population in the area is planning to buy a new car in the next year. Population in the area. So, you think, Spinach Chevrolet. They want to know the population in the area, which people are planning to buy a new car in the next year. So they want to know about everybody really in Thomasville. All right? So imagine you're the dealer at Spence and you want to figure out if everybody or how many of the people in Thomasville want to buy a car in the next year. Imagine if you did this. The dealer surveys the next 15 people who come to the car lot. The next 15 who come to the car lot. Are the results of the survey likely to be representative of the entire population? Okay. No, they're not. This is one of those convenience samples. People coming to the car lot are probably in the market to buy a car within the next year. It's not representative of the population in the area, everyone in the city, because not everyone in the city is going to come to the car lot. So, we would say this example is a convenience sample. The car dealer surveyed a group that was convenient to him. You could keep going and say a convenient sample. Again, that was one of those keywords in italics earlier. A convenient sample is not, emphasis on not, likely to be representative of the population. People already at the car lot are going to be more likely to buy a car. Okay? So this is an example of a type of bias. Those people at the lot are already going to be more likely to buy a car than the people not at the lot. All right, move to the next example. A restaurant owner wants to know how often families in his area go out for dinner. Okay, in his area. So again, the owner of Mom and Dad's wants to know how often people in his area go out for dinner. All right, he surveys 25 families who eat at his restaurant on Tuesday night. Are his results likely to be representative of the population? Yes or no? He wants to know the people in his area. So all the families in his area, how often they eat out for dinner. Well, the people he just surveyed, every single one of them is eating out. So this is not representative of the entire population because people in the restaurant are going to be more likely to eat out often. So we would say no, because people in his restaurant are more likely to eat out often. So again, that's another biased example. Because, and again, it's kind of a convenience because he just chose the people in his restaurant. That was convenient to him. Now, the next few examples are going to ask us to actually make some predictions. They're going to give us some numbers, and it's wanting us to use the information to make an estimate about a parameter or a prediction about what's going on in the population. This is what companies, restaurants, businesses must do in order to keep up with competition and make sure that they're making profits. So in a survey of 40 employees at a company, all right, so let's circle all the numbers here. You got 40 employees at a company that were surveyed. 18 out of those 40 said they were unhappy with their pay. Now you go to the next sentence, it says the company has 180 employees. So 180 is the total number of employees or the population of employees. 40 employees is the sample of that population. Predict the number of employees who are unhappy with their pay. So what we do here is we set up a proportion, okay? So we set it up like this. You got your unhappy employees in your sample divided by your employees in the sample, and we set that equal to your unhappy in the company, so everybody that's unhappy in the company over the total number of employees. Now, we have numbers for those three items that I just put the red dot next to. Okay, unhappy in the sample, that's 18. Employees in the sample, that's 40. Excuse me, not that one. The total employees we have the number for, and that's 180. What we're looking for is unhappy in the company. That's your variable. That's where we're going to put our X. So we set up a proportion. There are 18 employees that said they were unhappy with their pay. There were 40 employees in the sample. We don't know, that's our prediction, to predict how many are unhappy in the company, and we know that there's 180 total employees. So we've solved these type of rational equations before. We just cross multiply. We have 18 times 180 equals 40 times X. All right, when you multiply 18 times 180, you get 3,240. So we set that equal to 40 times X. If you want to solve for X, you divide by 40. 3,240 divided by 40 is 81. So 81 equals X. So our answer here, our prediction, would be that about, because remember it's a prediction, 81 employees are unhappy with their pay. All right, you go to the next one, and it's the same type of question. I want you to make a prediction. In a random sample of phone calls to a police station, 11 of the 25 calls were for emergencies. 11 of the 25, so that's 11 out of 25 were for emergencies. Suppose the police station receives 175 calls in one day. So 175 is the total in one day, 25 is the sample. Predict the number of calls that will be for emergency. So again, we got to set up a proportion. You got emergency calls in the sample divided by the total calls in the sample. Set that equal to emergency calls in one day over the total calls in one day. And again, we have three of these numbers. We got the emergency calls in the sample, that was 11. Calls in the sample was 25. Total calls in the day was 175. What we don't know, what we're going to make a prediction about, is the emergency calls in one day. So we'll set it up. We got 11 out of 25, because there's 11 emergency calls in the sample, 25 calls in the sample. We don't know X. We don't know the calls in a day. There are emergency calls in a day. And we know that there were 175 total calls to the police station. So I'm going to do it the same way. I'm just going to write it in a different order. Some of you might work it like this. Cross multiply, so you got 25 times x equals 11 times 175, which gives you 25x equals 1,925. And we'll divide both sides by 25. And our x value is about 77. So our prediction would be the police station receives about 77 emergency calls in one day. And it's all based on that proportion. All right, look at example 5 here. The manager of a store randomly surveys 20 customers. So that's good. But it keeps going. Of the 12 staff members, okay, so he surveyed 20 customers. He has 12 staff members. Of the 12 staff members, only three had shifts on the day of the survey. Of the 20 people surveyed, that's the customers, 15 thought the staff was not attentive enough. The manager decides to close the store for a day and hire a consultant to come in and train the whole staff on customer service skills. Did he make a good decision? Why or why not? Here's the thing. The day of the survey, only 3 of the 12 staff members were there. So that's 1/4 of the staff members. Not very representative of the entire staff. So instead of shutting down the store for a whole day to train the whole staff, those 3 really should have been trained. So, did the manager make a good decision? I would say no. The sample was taken from customers only experiencing 3 staff members. This is not representative of the entire staff. Now, if it had been something like 10, then that would have been different. But only 3 out of the 12, that's not a representative sample. All right, last one on the back. And this last question right here, this part, we're going to skip that, so you can go ahead and just mark that out. Okay, but we're going to answer the first part. It says a promotion on a cereal box says that 1 in 4 boxes will have a prize inside. Marion has bought 5 boxes but hasn't opened the prize. He decides the advertised prize rate must be wrong. Is he justified in his evaluation? Now, when it says 1 in 4, that's an average. Okay? He only bought 5 boxes. So his sample size is really too small. So no, because his sample size is too small. That 1 in 4 wins is an estimation. All right? If somebody buys 5 boxes, doesn't win a prize. Somebody buys 3 boxes and wins 2 prizes. So 8 total boxes were bought, 2 prizes were won. 2 out of 8 is 1 out of 4. Okay? So that's why, the sample size here is too small. All right? Now, if he bought 100 and didn't win a prize, then that number, that 1 in 4 wins, is probably wrong. Okay? But he only bought 5. So the sample size there is too small. Tomorrow you'll have some work with this, and really it's a lot of explanation and uh, reading and figuring out is it fair? Does everybody have an equal chance to get tested, to get surveyed, to be in the sample, right? And that's what you have to keep up with. So just make sure you have this, keep it with you. Make sure you look over those words because there were a lot of vocabulary words. Surveys, population census, sample, random sample, bias, underrepresented, overrepresented, statistic, and parameter. All right, so just make sure you keep this. Don't lose it. Bring it back tomorrow for the work that you're going to do with this information. Okay?